let's transition to our keynote speech. This year, we are very excited to welcome Dr. Rukmini Iyer to deliver our keynote speech. Dr. Rukmini Iyer joined Microsoft in 2010 to advance conversational understanding for personal assistant and moved to Bing Search Advertising in 2012 to accelerate machine learning in an advertising product. Her strong technical leadership and deep collaboration with partners has helped Bing achieve exponentially revenue growth over the last 8 years. Her team currently manages key infrastructure and algorithmic components from core machine learning, from core NLP to NLG efforts, to machine learning of user and advertising signals, to managing the online auction and product metrics. Prior to Microsoft, Rukmini earned her PhD in electrical engineering from Boston University in 1998, working in speech recognition and NLP for the first 10 years at BBN Technologies and Nuance, and distributed machine learning and AI at Yahoo. Her current interests include practical application of reinforcement learning, Causal ML, using AI-driven automation to improve long-term success of small businesses. We're excited about this opportunity to hear directly from her. Just a quick note to please post your questions in the Q&A tab instead of chat. Rukmini, please start sharing your slides, and off to you.
Good. Hopefully you guys can all hear me. Let me just share my slides.
Yeah, we can hear you well.
You can see my screen.
Not yet.
Okay, you're ready to go. I want to actually congratulate the 4 leads here. They have done an awesome job of putting this conference together. My history with WIDS goes back to, I'm based in the Bay Area, and I've been working with the Stanford folks who started WIDS for a really long time. So my history with WIDS goes back all the way to the first conference that they held. I think I ran a workshop at that conference. Then I've been on panels, and for the last 3 years, I've been working on the WIDS High School Outreach Program, which is trying to get data science in girls' mindsets early on. We thought high school is good enough, but studies now are saying that we need to probably even go into middle schools. So I'm super excited to be here with all of you, and so do ask me some hard questions if there's time left for Q&A. And as Mengyan already talked about, I've been working in machine learning and AI for the last 20-25 years since I came here for my PhD. So I'll start with a quick introduction of who I am, and I wanted to do.
Rukmini, real quick, we are not able to see your slides.
Oh, you're not able to see my slides?
No.
Okay. Let me reshare, maybe. It says I'm sharing my screen. Share my screen. Do it again.
Oh, it seems some people can see your slides actually.
I see. Okay.
Okay, everyone else sees it but us, so we're fine.
Okay, let's get going then. So I wanted to start with, my personal introduction. I have 2 kids in college, the one in the first and the fourth photograph. I'm married to a very supportive spouse right in the middle. My mom, she's 82 and in Australia right now. And we rescued a dog in the middle of COVID, and his life has been, someone told me that, COVID was kind of invented by dogs. They get their owners right next to them all the time. So that's me for a personal introduction. And for professional introduction, I came here to do my PhD. And at that point in time, my PhD is in statistical language modeling. Language modeling was not as cool as it is right now. So this is a long time ago. Someone just reminded me it was in 1998. I stayed a scientist for a really long time, for 10 years, in AI R&D across a lot of different companies. And I actually joined Microsoft as a scientist. And then I took on management roles, and now I run the advertising, almost the entire advertising engineering organization. And on the right-hand side, I just talk about the skill sets that I've acquired. So I started in statistical modeling and NLP. And luckily for me, when I moved to Yahoo, I really got into machine learning, A/B experimentation, and I built the first distributed machine learning on Hadoop. It wasn't called Hadoop then, but I remember going and asking for the machines to set up a maximum entropy machine learning distributed learning system. And then when I came to Microsoft, I would say I've learned even more. I got into metrics design, obviously deep learning, product design and analytics, and now I'm most interested in causality, but I'll say it's a work in progress. So I actually wanted to spend the time today to go through my experience of designing an AI product, and I thought it would be really useful for folks here who are product scientists, data scientists, statisticians, the mix of the skill sets that are probably in the audience today, and the thought process of designing and then executing an AI product, which means you're using, real AI in a real online system that actually real consumers are engaging with. So, and because I'm most familiar with advertising for the last 10 years, I thought let's design an advertising product together. So as in most products, when you put your product together, you're really looking at who are your customers for the product, or what I call participants here. So in an advertising product, you have your retailers and your sellers who are trying to get leads. They're trying to get users to click and come to their landing pages, buy from them. They're looking for brand awareness, and they're willing to spend on marketing as long as they get a reasonable return on spend. Then you have your consumers who are coming to your platform, be it Facebook search, Google search, Bing search, news feeds, and these users are really coming to interact with your app. And while they're interacting with your app, they also see hopefully relevant ads. So they want relevant results. If they're buying something, they want to land on, not spam, but good product pages. And in the end, they want deals and, an economic purchase. And then you have the app provider, who I call publisher here, for instance, a search engine. And what they're really looking for is for users to engage with their app, be happy with their app, and at the same time, advertisers to advertise on their platform. And hopefully there's a happy marriage between the users and the advertisers. And I call that happy marriage long-term revenue from advertising. Now, the blue sky objective, if you sit down and are working this out on paper, is to maximize long-term revenue. And what is revenue? Let's break down revenue into the combination of things that generates money. So first, your app needs users, and as users grow, your app can make more money. Users engage with your app. For example, if it's a search engine, they issue search queries. So the number of queries they put into your app is essentially, their engagement with your app. Now, for these queries, you may show ads. So the ads that you can show per query also, it can actually contribute to long-term revenue. Hopefully, the users click on these ads, and every time they click on an ad, you get paid. It's a cost per click marketplace. Now, if you write this down, and you'll see that the first two and the fourth term are essentially a function of the user and the system. The user needs to do something, and the system needs to make sure that they're providing relevant results so that the user then clicks on the ad. And the ads per query and the costs per click are a function of how many advertisers you have in your ecosystem. And then, of course, that you need to be able to match these ads to the users. So you have three things that are playing here. You have the user, you have the advertiser, and then the system, which is the marketplace that's taking the user and providing them to the advertiser. And so if you take this as your blue sky objective, so you have your basic math ready. Now let's formulate, how are you going to design this? So the first assumption we'll make is you need the number of users for your app and them to engage more with the product. So satisfied users will engage more with the product. So let's say we have a way to measure user satisfaction. And in this case, we don't really, long-term satisfaction is hard to measure. So let's say we're going to measure short-term user satisfaction. The assumption two that you're going to make is that if advertisers see good leads and good return on marketing spend on your product, they are going to increase their spend. So again, satisfied advertisers will increase spend. And so we are going to try to measure long-term advertiser spend, and maybe short-term advertiser satisfaction can be a proxy for this long-term advertiser spend. And so you want to maximize your revenue, your long-term or short-term revenue, given that your users are satisfied and your advertisers are satisfied. And so this is frequently formulated as an optimization problem. And let's assume that all your short-term proxies, you have great metrics for your short-term, your advertiser satisfaction and your user satisfaction. So the optimization problem you're trying to do is you're going to maximize your short-term revenue, given your users are satisfied in the short term and your advertisers are satisfied in the short term. So this is a constrained optimization problem. Okay, so next you have gotten your formulation. So let's go on to picking your short term, your user and your advertiser metrics. And a lot of folks actually start with thinking that metrics should be relatively straightforward. I mean, clicks on an ad should count as a metric. In fact, metric design is actually the hardest problem, and you should also not get married to your metrics too early. In fact, I have evolved from, if I think about it, 8 years ago, we had 2 metrics to now we have more than 12 user and advertiser satisfaction metrics. So that constrained optimization problem, the more metrics you add, the more constrained it gets. But those metrics have been evolving over time. So I want to give you an example of how not to pick your metrics. And in fact, if you have good metric design folks in your organization, they are incredibly valuable. So let's look at this example here. So the user is typing how to pick a mattress, and the left hand is your control, where you're showing 4 ads here. And at the bottom of the page, you can see the first organic content popping up, which talks about science-backed tips to pick the best mattress. On the right-hand side is your new treatment. All you have done in this treatment is you have increased the space between ads. When you increase the space between ads, what happens is that obviously the relevance of your ads is not changing. You have pushed the organic content below the fold. So you can't actually see the science-backed tips to pick the perfect mattress anymore. And what that does is it actually increases, you're increasing the clicks on your ads. So your treatment is actually going to increase your ad click-through rates. But is this really the best thing for the user? And so is the page with only ads visible better for the user? This is just an example to say that, it's easy to pick a metric that really correlates with revenue, but if you're really looking after the user satisfaction and the advertiser satisfaction, you want to spend a lot of time on your metric design. So what do we do now? So we have, how do we measure user satisfaction in the trenches? So we use relevance metrics. These are user agnostic. So just look at the ad and the query and then get labelers, human labelers to label and tell you, hey, is this ad relevant to this query? So that is user agnostic. You can also use implicit user feedback metrics. So click-through rate is a great proxy. If the user clicks and lands on a page and they don't spend much time on the page, then you actually wasted the user's time and they have to click back. So short dwell time click rate could be a negative metric. The amount of space that your ads take before the organic content shows, that can itself be a negative metric. And ideally, you want a combination of these metrics. As I said before, there's no one perfect metric. And in fact, you should be very comfortable with evolving your metrics over time. How do we measure long-term advertiser satisfaction? So what are advertisers looking for? They really want users to come to their page and stay on their page and interact with their page and buy something. So you look for long dwell time, click-through rate. You look for conversion rate. Are they buying something on the page? You're also showing the advertiser to the user for certain queries. What is the quality of that match? They also care about that quality of the match. So say these are the metrics that we're going to go with. So you have your optimization problem and then you have your metric. So now let's execute. This is our design of the product. And so we're going to execute on this design. So this is my optimization flow. Most of you will say, hey, I know exactly how this works, and you should. So the user's coming to your app, they're typing in the query Surface Pro X, and you are going to show them ads such that they'll click on the ads, and you will make some revenue. At the same time, you want them to be satisfied with the ads you show. and you want the advertiser to get, either conversions or long dwell time clicks. So this is your constrained optimization problem. And then, okay, so this workflow is very straightforward. So the query comes in, you're going to match your ads to this query. You want to make sure that these ads are relevant, so you're going to filter the poor matches. The technology has gotten really complicated now. So in fact, most advertisers, they can just give us a landing page and we can generate the ads for them using NLG technology. So we generate the ads and compose the ads. The next thing is, remember, in your optimization problem, you have all these metrics. None of these metrics are known, so you've got to predict these metrics, including revenue. So revenue, for instance, is what is the likelihood the user will click on the ad and what's the price you'll get for this ad. So you need to predict all of your metrics. You predict your quality metrics, you predict your user response metrics. Then you go into the optimization flow where you say, hey, here are the ads, here are all the probabilities associated with the different metrics that I care about. Can you go ahead and optimize, run the auction, and then show the ads? Okay, so this was a race through all the workflow boxes, and each of these boxes is essentially an AI application. So I'll show you a slide in a bit where I'll tell you that pretty much all of these boxes have state-of-the-art AI that happens in these boxes. So we use, state-of-the-art natural language representation, NLG. We use graph neural networks. We use reinforcement learning. We use contextual bandits, and we use causal ML. And I don't really have the time to go through all these boxes, so I picked 2 of them. And my goal here is to work through these boxes and tell you that it's easy to imagine how to build the box, but then when you are in production and you have very low latency requirements and you are operating, the app has to be very responsive, you do hit a lot of challenges in the trenches. And so we will walk through 2 boxes and then we'll talk about what are the challenges that we typically see. So let's take the first box, which is matching an ad to a query. This is a standard retrieval problem. And we used to treat it as a syntactic matching problem. So you can use regular information retrieval techniques. In about 2016, 2015, 2016, we switched to a deep learning infrastructure and paradigm. And in that deep learning paradigm, you had your query represented by an embedding vector. You had your ads represented by different types of embedding vectors. And we had a neighborhood graph search that would then match these queries with the ads. This was a breakthrough. We actually saw very, very significant revenue gains. And then all the things that we built in the product, for instance, the neighborhood graph search, the deep learning vector, it got into a deep learning vector service, and then it was finally open source. And so we have been in the deep learning world since 2015. And if you look at where we are right now, we use state-of-the-art deep learning both for natural language representation and for natural language generation. So I give you an example here of natural language generation. The query is image royalty-free, and the keyword is what the advertiser gives us, saying, hey, these are the types of queries that I'm interested in. And so we take the query and then we can generate the keyword free copyright images. And here it's a traditional NLG. We have, in this case, we used BERT as our base representation. We fine-tuned it using query and keyword training data that we had. And then we had a customized decoder. And in this customized decoding, we were trying to generate keywords that the advertisers have given us, so it's a constrained try. And this went into, early 2020. We had this live in our ecosystem. And I can tell you that deep learning, we probably have, if you can imagine something in a research paper, some version of it is in our production system right now. And so there are significant challenges with using deep learning in production. If you take something like BERT, you can definitely try to build something offline, but if you want to serve it online, the serving costs are high and the latency is too high. So knowledge distillation of very large deep learning models to student frameworks, this is something that most production teams that use deep learning are very focused on. the inference costs. So say you even decide not to serve your deep learning model online, but you want to score your documents or your queries offline. The inference costs are quite expensive. And so we have dedicated optimization, which we actually contribute back to open source, where we are trying to make the inference as painless as is possible. And then if you are doing something for a paper or for a Kaggle competition, you can stay, within the constraints of that problem statement. But when you're building a product, and if your product is worldwide, then you can't just build models for English. You really need to be able to handle hundreds of languages. And so these are, genuine production scenarios. And if many of you work in AI products, none of this will be surprising to you. So I will walk you through two examples. So one is we developed our own student framework for deployment efficiency. Where it's a twin tower framework where the query has its own embedding tower, and that is run online. But the document actually goes through an embedding tower offline. And so that saves you the cost. In the queries, there's a single query, you have lots of documents. So if you can do the embeddings offline and serve them online, that's a lot cheaper. And this twin tower architecture actually, the knowledge distillation, we didn't lose too much from using, from not using the very large BERT models. And as we improved this twin tower architecture, almost all the prediction problems that I showed you on the slide, the workflow slide, started leveraging this twin tower architecture. So knowledge distillation in itself is becoming a very interesting area because it allows you to translate a lot of the research that's being done in deep learning to production. And when we launched this in last year, we saw a significant improvement in query keyword defect rate, which is the matching quality that I talked about earlier. The other one, big one I talked about is cross-lingual models. You have to scale to hundreds of languages. And so luckily for us, both in the open source as well as within Microsoft, we have really large-scale multilingual language models, language representation. Within Microsoft, we have Turing, which is our equivalent of, actually BERT is old school. So whatever is the latest, it is our equivalent of the very large scale representation models. And so we have very powerful teachers. As I already mentioned, we are working on lots of student frameworks. We have effective students. And for multilingual, for global settings, we observed we didn't have really as much training data, for fine tuning as we had in English. So we ended up also doing multitask learning. And the table below just tells you that, you actually can see significant improvements from using these very large representation models and then distilling them to the student model. So again, another thing that's solvable, but there is a lot of effort that you need to put in to make sure that your product is truly global. And then I'll move on to the user response, which is predicting what is the user going to do when you show them this. And I had three metrics. If you look at the green box below, the probability of click, will the user click on this ad? If they click on this ad, will they stay on the page? This is the dwell time metric. Is this going to be a good click? And obviously, if the advertiser is willing to give us conversion data, will the user convert given that they click? So you have one unconditional probability in some sense, and then you have two probabilities that are conditioned on the click. Okay. So this probability of click model is in fact the heart of the any advertising ecosystem. And in fact, most of the papers that you will see will be in this space. And in fact, these models have been extremely large scale for a very long time, just because they are so key. This is how you estimate what revenue you're going to make. And so we have a very, very large scale model. In fact, we have what is called a combiner model, which combines a lot of learners. And one of our strongest learners is one that has about 20 billion parameters in total. It trains on more than 2+ years of data. And it's a deep learning model, and we use dropout to have confidence estimates. So this is, basically a mega large scale model. Now, one thing you'll notice in that diagram below is that I separated out position. So position is where did the ad show on the page? And if you're aware of click modeling, you probably are already going to know what my next slide is about, but why is position being separated out? And so one of the key things that you learn as soon as you do click modeling, in fact, most people are super excited about modeling clicks because the data is plentiful, right? I mean, you get lots of clicks, you don't have to label. The problem with using your observational data is that there is a causal dependency between, your click actually depends on two things. Your click depends on your position. The click obviously depends on the ad quality. Is the ad relevant or not? And the position depends on the ad quality. So if you think about how you have optimized things, your model is going to say that this is a relevant ad, and if it's a relevant ad, it has a higher chance of ranking higher, right? So that's the connection between ad quality and position. Now, this means that someone who shows on the first position is likely to get more clicks than someone who shows in the second position. So there's a bias in the feedback that you're receiving. And if you don't take care of this bias, then you are going to end up with a model that will reward the first ad, the ad that shows up in the first slot, both for its position and quality. And so you need to break that connection. So how do you break that connection between quality and position? The typical way you do it is you randomize. So you get a set of ads and then you randomize the position so that you collect at least some amount of data where ad quality is not driving the position. So you essentially intervene in your ecosystem. One thing that happens here is, I think somebody's mic turned on. So Shivani, did you have something to say? Okay. So the issue with randomization is that obviously this is a first order user cost. You're showing not such a great ad on the first position. So you have unhappy users. You also make less money. And so randomization has a real cost. And so you randomize, you collect very little randomization data, and you have to really utilize all the data that you get. A lot of folks, when they are using click models, they miss this piece. And so that's why I'm talking about it, because I think it's interesting to remember this when you're using any user feedback data for your modeling purposes. So we have done a lot of work in this area. In fact, we had intuitive ways of debiasing the data. And as causal machine learning is really taking off, we have done some joint work with MSR to do causal transfer random forests. And the idea is very simple. You learn your model structure and your decision boundaries on the little amount of randomized data. Once you have that model structure, then you kind of calibrate all your leaf nodes using all the observational data. And this works, wonders. Now, we have also used this for our deep learning models. And I think we saw not just significant gains in terms of click-through rate, but we also saw a significant improvement in the stability of the system once we included this in our modeling. So I talked about only two of the boxes, but as I mentioned, basically advertising is a full-fledged AI ecosystem. You're solving a constrained optimization problem where all of the things that you need are required to be either predicted or inferenced, and so you end up building pretty much an AI stack. And I didn't even talk about half the problems like fraud, policy violations, spam users. You have just a lot of interesting problems to work with in the space. Now, on the right-hand top, I show you, that this comes with you really do need to build a very, very strong experimental ecosystem. Because once you have these about more than 200 AI models in place and you're iterating on these models, your experimentation agility, your experimentation robustness determines how successful you're going to be. So in our case, we have a very state-of-the-art experimentation system. We run about 1,800 experiments. Just for the search ecosystem, we run about 1,800 experiments a month. Some of these experiments are successful and they go into production. But before something even gets into an online experimentation, there are thousands of experiments that happen offline to first ensure that your model is really improving. Okay, so My next section is about you have designed your AI product, you've executed on it, you now have 200 AI models humming along in your product. What do you look at next? And I won't have time to go through these slides. I actually don't know how much time I have, so I want to leave at least a couple of minutes for questions. Is you need to, once you have all these AI models in place, you can say, hey, I'm done and walk away. In fact, you have created a very complex system that's generating revenue, that's generating clicks to advertisers, that's helping users buy things. So now you've built this entire ecosystem. You've got to make sure that it is robust, stable, and in fact, I already talked about experimentation. To be able to keep this humming along, we have in fact parallel flight lines, so every model can get its own flight line. Now, obviously, in the end, they all come together in a constrained optimization. So you must be wondering, like, that means that these models are interacting with each other. So figuring out what kind of interactions happen, if these interactions happen, can you alert and let the experiment owner know that, hey, the metrics in your flight are actually impacted by this other experiment that's running. Statistical significance. All of these become things that you need to, the foundation of your experimentation system is essentially what drives how robust your marketplace is. In advertising, we have evolved to where we even allow advertisers to experiment. So we even provide experimentation as a service to our advertisers. The second thing is your model metrics. Each of your model needs to be evaluated continuously and in aggregate as well as for slices. And every time you have a new model that's going to go in place, you need to check, how is it doing on very key critical slices. So in fact, for click models, for instance, we look at how it's performing on the randomization data, on the exploration data. But the slices that are really key are cold start, where new advertisers coming in or new users coming in, places where you have missing features, categories of advertisers like the small business versus the very large retailer. Large retailers can really optimize their creatives and their keywords. Small advertisers struggle with it. Feature monitoring, what you train offline sometimes is not what you get online, so online parity. And then the final layer that I talk about is advanced analytics, and this is a passion of mine. You really want to know when something changes in the ecosystem, why is it changing? So some form of explainability. Explainability sounds, really out there, but understanding if you forecasted that this is how your clicks are going to look like, and what you see in your marketplace is something different, can you explain what changed? And to me, if we can get to this place, then we can backtrack to which model is causing what changes or what else in the ecosystem is making these changes. But the causal graph that surrounds your entire ecosystem is actually extremely complicated. I mean, I made an attempt at the bottom below, and in fact, we quickly realized that politics, even there's a connection between politics and advertiser. So this is not a causal graph that you can easily intervene and control. But there are ways in which you can do simulated baselines. You can, in fact, what I talk about next, and I'm going to skip it, is basically you can train a model on your past period and then say, hey, if nothing changed, if I just took the model or the user model that I had in my past period and I predicted what would happen on users in the current period, what is the KPIs that I would see? And you can then look at the actual KPIs versus the predicted KPIs, and that becomes your synthetic control for the analysis period. And we in fact do this for lots of our KPIs. And in fact, this really tells us that sometimes, for instance, very recently, and COVID has been a great tester of these ideas. So recently, we started seeing advertisers coming back. In fact, even travel advertisers started coming back. And so we started seeing numbers changing every day that looked, we were not forecasting or predicting these numbers. And in fact, this really explained to us is that the user behavior was changing, but really what was changing was the advertiser behavior. And so trying to explain your ecosystem even if it's a really hard problem, I think it helps you figure out, what are your choking points. It really gets into the heart of explaining, why you built this product and what parts of the product do need to evolve to become more explainable. Okay, so where do we go next? Obviously, I talked about causality, and I said it's a work in progress because I find the area really fascinating, but also very challenging. And so I started with a quote from Judea Pearl, and the Book of Why is the fictionalized, the murder mystery version of his actual textbook. But if you haven't read one of his books, I highly encourage you to read it. And I took something out of his book where he talks about, the ladder of causation, where we are in the bottom of the ladder is where he believes most present-day machine learning algorithms lie. They are an association. You look at your hindsight data, you look at the patterns, and then your model learns this hindsight data. And the larger our models become and the more complex our models become, the better they're able to memorize what's happening, what has happened in the past. I actually believe we are in the middle. We are in the intervention stage. We are actually doing and playing around with the system through randomization, exploration. All the contextual bandit algorithms are squarely in the middle. And where we are actually trying to see what would happen if we change things. And of course, the last stage is the counterfactual stage where you say, you don't even have to run an experiment. If I change this model, what would the system behavior look like? In fact, we have a counterfactual system that can do this for simple changes. And we are going towards, if you can construct the causal graph, in fact, you can even predict more sophisticated changes in your counterfactuals. But that is on the top rung. Hopefully I gave you guys a good view of kind of, how do you start? Like, what do you think of first? Then how do you build it out? And then once you build it out, what are the challenges of maintaining a robust and stable AI ecosystem? So I'm going to stop with that. I work at most of you already know, I work at Microsoft. I'm part of the Web XT, which is the web consumer team. We own many of the consumer apps, the Bing search engine, the Edge browser, the news feeds, content feeds, and in all of these areas we are hiring right now. So if you're interested, please go ahead and look at careers.microsoft.com, or upload your resume. I think there's a resume bank, so upload your resume to the resume bank. I hope this was useful. I'm happy to take questions. Shivani, I don't know if we just do questions on the chat, or do we want to do some other way? But please do start asking me questions and ask me some hard ones.
Thanks, Rukmini. We have some awesome questions, and Catherine's going to moderate them for you. So get ready for some good hard ones.
Good, that's great.
Yep. All right, my camera won't turn on, but I'll just read them out loud. And thank you so much for this talk. It's been really insightful. So we have one question from Shweta Singhal. She said, Dr. Iyer, it's been really insightful to see the complicated metric definition and contribution to open source. My question is about making advertisement secure and private, which is a crucial piece of any advertisement. Could you put some light on how your team is handling that user click, personal data, and any suggestions or message you want to give everyone in that industry?
So that's a great question. And in fact, privacy is, especially over the last couple of years, it has been top of mind, not just for advertising, even for ecosystems that are using personalization as a feature. And many of us realize that personalization does play a very important role in how an application becomes relevant to you. Like I use TikTok. If you use TikTok, you know that they are heavily personalized. And in fact, the personalization is what makes that app really, actually, it's really fun for me. But really fun. So we don't want to lose those aspects of personalization that helps the user get the most out of the product. At the same time, we want to make sure that the data is treated with the utmost respect. And from our perspective, we honor all the privacy policies, just out of the bat. And if you work in advertising space, you will be very aware that privacy is different countries have different privacy policies, different states. California has its own privacy policies, so we adhere to all those policies. All the P2 data, which is the very personal data, is either anonymized or we kind of diffuse it so that there's some differential privacy aspects when we do advertising. And then do use some of the user data if they're opted in for personalization. And again, I think personalization is something that's key to making the product more relevant for the user. So we do want to maintain some amount of personalization in the product. Hopefully I answered your question. The changes that are happening in the privacy space is opening up its own set of AI challenges. So there's federated learning, there's differential privacy, there are entire proposals out there in how the user information can be maybe held by the browser or by a trusted proxy server, so that advertising actually has only information that's private information. So there's an entire not just a work stream, but an entire ecosystem behind the privacy space that Microsoft is a very, very active participant in.
Great,
Hopefully I answered
thank
your
you.
question. Go ahead.
Thank you for that answer, Rukmini. Next question is from Rishik Dar. Dr. Iyer, that was a great little insight into the metrics. Thank you. Do you have proposals on how to take a systematic approach in involving metrics iteratively as we develop products and solve new problems that don't yet have a measure of success well defined?
Right. So my standard approach is to start simple. So you start with your simplest set of metrics that you can derive. And then what we sit and do is we look at the metrics and we try to design experiments that will break the metrics. So the example I showed you of how not to is something that we actually started thinking about. If we used only clicks as our metric, how could we break it? This sounds odd, but I actually highly encourage you to sit and do this. To take a metric and see how would you fake that metric. And that kind of opens up areas that helps you kind of design the set of experiments to challenge your metrics and evolve your metrics. The other framework that we have is to really test out the theory that you have. So for instance, if you say that if I show more relevant ads, I am going to get more long-term usage out of the user, then let's run that long-term experiment. And oftentimes we actually run these long-term experiments, and in fact, we have even run geo experiments where an entire country has been treated to much higher relevance bars. And sometimes your metrics will not move. And that's a little bit disappointing. But remember, the null hypothesis is a real hypothesis too. So I think, the way to design metrics is to come with first your simplest set of metrics, and then to challenge those metrics. A lot of us, I think, especially engineers like me, once you get a metric, you want to kind of optimize the hell out of it. And while I think that is something that you need to, for your teams, you do need to say, hey, these are the metrics you're going after, and these are your constraints. You do want them to optimize it. You need like a side channel that's always trying to point out the flaws in your metrics. Hopefully this was kind of an interesting insight, but I really appreciate the metrics design folks who are always telling me, oh, this metric will work, except in these situations.
Great, thanks. Next question is from Rukin Duskun. Dr. Iyer, do you attribute a conversion to the last click, or do you consider TV ads, emails, previous clicks, etc.?
That's a great question. In fact, conversion attribution becomes very challenging, not just here, but especially as we evolve into the new privacy space. Conversion attribution is the first one that's going to have really big challenges. We do a combination of last click attribution and soft attribution for past activities from the user. In terms of TV, we don't have really TV ads, and so we don't. If we get data, we do get some data from the advertiser that tells us that, hey, these are the past interactions from the user, so you can do a soft attribution. But oftentimes we have entire blind spots as to what the user activities looked like before they bought. And so the last click attribution is still the most dependable attribution that we have.
Then we have one more question from Judith Yemeli. Dr. Iyer, simple one from me. How do you balance between short and medium or long-term metrics, as one might not necessarily be in service of the other?
You're absolutely right. So for instance, click-through rate by itself may not be in service of the long-term user satisfaction metrics. And what we have come to realize is that there is really no one metric that can meet all your criteria. So it's good to have a set of metrics. And so that's why we evolved from just using click-through rate to click-through rate, dwell time on the landing page, conversion. These are all metrics that are kind of, they all correlated metrics, but at the same time, they all kind of chip away at some of the flaws of the basic click-through rate metric. So having a set of metrics rather than one metric, I mean, you may feel this urge to really design that perfect metric. I would tell you that you're much better off with a set of metrics, because that's the best way to identify the blind spots in metric design. So having a set of metrics, and in fact, we still continue to use the labeling, the user agnostic relevance metrics, because they point out issues sometimes that none of our user metrics can really showcase. And so I would say a set of metrics, and then between the short term and the medium term and the long term, you have to run those medium term and long term experiments. And these are really hard experiments. In fact, there are some very interesting papers on long term experiments. And if you get a chance, read them, because this is a very challenging area.
We don't have any more questions, but we can pause for a few seconds to see if anybody else comes through. Someone posted it wasn't in the Q&A, but this question was in the chat. He said, great talk, Rukmini. Just a quick note, you mentioned using dropout for calculating uncertainties. It has been shown that, or I don't know if this is a question actually. Ignore what I just said. It wasn't a question.
Thank you, Sankalp, for that comment. I think we definitely observe that a lot of folks will build models without actually producing uncertainty estimates or variance around your model estimate. But in fact, I think in almost all cases, exploration is a must. So if you have any model in place, I would say if you have a checkbox as to what that model needs to satisfy before it goes online, exploring the model's decisions are a must. If you don't do it, you're not really going to get great training data once your model is in place. So providing uncertainty estimates, or even using basic rules like, hey, I have n number of missing features, my uncertainty must be higher. Even using simple rules to make sure that you are exploring your model's output, this is really critical if you're working in that space.
Perfect.
I see one more question. In fact, I actually, Ishwarya, I think, in fact, I see this being a big challenge, because every time I design a new metric, this is the first question I get from my engineering team that, oh, we just learned how to solve for this metric. We have year-over-year charts, which tells us exactly how we have improved. And now we're going to throw all that away and come up with a new metric. And one way to generate baselines, if it's possible, is to run your new metric over old data. In fact, what we do is we have a repository of interesting experiments that we kind of store the data for. So if you had an experiment, for instance, say I increased ad space, but then dwell time actually improved, or click-through rate dropped, or something interesting happened that you were not expecting, then we store the data from that experiment, so that when we design a new metric, we go and see what would the behavior look on this very interesting experiment. So if you have a metric design team or an experimentation team, they would definitely to give you ideas as to how can you go back propagate the new metric that you created to the past. So that's one way of doing it. I mean, there are other ways of doing it where you figure out the correlation between your new metric and your old metric and use that as a way to have the past trends available. And in some cases, you just don't, it's just a new metric. And so you want to start from scratch. In those cases, we typically put it into our scorecards, our experimental scorecards, and we watch that metric for at least 3 to 6 months. So we have some understanding of how that metric moves before we start taking goals on that metric or designing, how are we going to train models to predict that metric and optimize and constrain for that metric. Hopefully, Ishwarya, I answered your question.
We have room for one more question from Anupama Garla. So this was super informative, as I've only worked in much smaller organizations with basic algorithmic applications. How well defined are the roles of people on your teams? I know you mentioned the metrics person. What is the breakdown of those overseeing bigger pictures and those drilling down?
So that's a great question. In fact, I should have had a slide on that. So we have 3 or 4 different roles that data scientists play in the team. We have the hardcore machine learning scientists, who are the ones that are working on the deep learning models, even on the very large scale click prediction models, or on problem statements where we really don't know. For instance, if you want to do online learning, you want to optimize at runtime, how would you design that ecosystem? So we have some very deep machine learning scientists who work in those problem areas. We have applied scientists. So I would call myself an applied scientist, where I marry machine learning with production systems. So folks that work on knowledge distillation, inference optimization, putting these production systems online, these AI models online, and how do you measure, model, monitor these models? The applied scientists are the folks that are most interested in not just the depth of the machine learning, but they're really interested in bringing it live. And you will notice that there are folks who have this combined engineering machine learning mindset, and they are actually extremely valuable for your organization. Then you have the data scientists, and here you have 2 sets of data scientists: the folks who actually are typically doing the metrics, doing the experimentation, focusing on flight interactions, focusing on explainability. You have those set of data scientists, and then you have analysts and folks who are looking at the business metrics and figuring out what changed, how did it change, how do I alert on these changes, does this change imply that something has gone wrong in the system? So we have a whole set of data scientists who are more operational data scientists. And all these 4 roles are kind of, to some extent, fungible. So a lot of our machine learning scientists can also look at the the trends and the patterns and help us debug. The applied scientists can actually swing either way, because they are really interested in bringing something online. So in fact, they are very good at pointing out flaws, because many of them have worked in production AI systems for a while. So from that perspective, I think all these roles are somewhat fungible. But in the end, many folks have like key interest areas. So for instance, if I hire, statisticians, I always give them the things that they care about the most. Like, are my p-values being computed right? And you'll be surprised, that because the experimentation systems change all the time, they're not static. Your p-value computation could be incorrect. And so doing a thorough checks and balances, if your experimentation is working as expected, you have folks who love that area and will spend all their time in that area. And so we hire statisticians who are very specifically in that area. Sometimes we hire mathematicians who love solving optimization problems. And so I would say that you have all kinds of data scientists, and the roles are somewhat fungible. It really depends on your interests as well as your ability to learn a new speed.
Thank you so much, Dr. Iyer. This concludes our keynote portion. We really appreciate you joining us this morning as our keynote. Everyone's loving you on the chat. We all really learned a lot. So thank you so much. Now we are switching back to Shivani to launch